Hi, I'm Lawrence Harrington.
Hi, my name is Rachel Sosa.
Hi, I'm Oscar Lizondo, and this is our presentation on sketching derivatives. Our references for this presentation were the textbook, Khan Academy, and Learning Module 2.7 on Quest. A fun fact about sketching derivatives: the derivative is just the slope of the tangent line. When the derivative is positive, the function is going to be increasing. When it's negative, the function will be decreasing.
Okay, so now we're gonna be sketching the graph of a derivative for the range of between -1 and 1. So the first thing we can notice is that you can interpret the value of the derivative at any particular x-coordinate as the slopes of the tangent lines on the original graph, as Oscar was just saying. So the easiest ones are when the slopes are 0 because our line will be kind of flat. So we can notice that whatever the tangent line is horizontal, the slope of the tangent line will be 0. So we can notice that at about negative 0.5, our derivative will be 0 since the tangent line will be flat. And the same thing happens at x equals 0.5. So our f prime of x will be 0 at that point as well. And from negative 1.5 to negative 0.5, the slope of the tangents will be positive because at any point in that range, if you get the tangent, the slope of the tangent line, it will always be positive since it's increasing. So from negative 0.5 to 0.5, the slopes of the tangents will be negative because we see that at that range, the slope is decreasing. So at any point there, if you get the slope of the tangent line, at any point, it will be always negative. And from zero point 0.5 to 1.5, the slope of the tangents are positive, again, because if you get the slope of the tangents at any point there, it will always be positive. Okay, so here I actually graphed the derivative. So again, we can see that the slope of the tangent at negative 0.5 and 0.5 are 0 because in the original graph, the slopes of the tangents are 0. So right there, our derivative graph will be crossing the x-axis at those points. So at negative 0.5 and 0.5. So from negative 0.1, from negative 1.5 to negative 0.5, our tangent slopes are positive. So the values of f prime of x are positive, and we can see that in our derivative. And from negative 0.5 to 0.5, the slope of the tangents are negative in our original graph. So our values for f prime of x are negative. And finally, from 0.5 to 1.5, the slopes of the tangents for our original graph are positive. So we know that f prime of x will be taking positive values in the y-axis.
So on problem 2, it asks us to sketch the graph of a function that goes through the origin, 0.00, and whose derivative looks like the graph given for negative 1.5 less than x, which is less than 1.5. So much like the applied knowledge Rachel was talking about, we're just like doing the same type thing because it's like the same problem. We're just making a different adjustment because this is 1.5, negative 1.5 to 1.5. So in graphing this, we'll just set our values the same up to negative 1.5, and that goes up at the start because our y value should be positive because we're crossing the x-axis at the end, but the y value should be positive because we're going up. And we have to go through the origin at 0, 0. So we will go back down and we will go back up because we're going to 1.5. So from negative 1.5 to negative 0.5, our y values must be positive because it is above the x-axis. And our previous maximum and minimum, like the problem Rachel gave us, of f prime of x. So now leading us into our graph, decreasing going towards the origin, then back up again, going from 0.5 to 1.5. And that's like the sketch of the derivative.
Now that we've given you all our explanations, here's a practice problem that you can try on your own. Make a sketch of the graph of f of x equals sine of x, and below it sketch the graph of its derivative. A little extra portion if you want to make it a little bit harder. Try and guess the formula of f prime of x from its graph. That is the presentation. Thank y'all. We'll be happy to answer your questions at the end.
Thank you.